Hi, my name is Michaels. I'm CEO of CENOS. I'm PhD in applied physics myself. All my professional life, I was doing numerical modeling. And now I'm really impressed how easy it is to do radio frequency design with CENOS RF 2.0. Let me show you. You can use your design prepared in any CAD software and validate the design in CENOS simulation software. There are just 3 steps to do it. The first, geometry, then second, physical settings, and the last, result analysis. Meshing is the fourth and optional step since the software can do automatic meshing, but you can also adjust the manual meshing if you want. I'm going to validate IFA antenna design today. The first step, I choose from CAD approach, and I load step files which I prepared in my favorite CAD software. So once the CAD file is already loaded here, the software asks if I want to generate the air domain or enclosure automatically. So I go for that. CENOS RF 2.0 support different types of RF problems. Microstrip PCB antenna, wire antenna, reflector, multi-port network, waveguides. But it's not the limit. The software is good for any RF task. So my IFA antenna is a microstrip antenna, so I just select microstrip here. So now I just need to assign the rows for the geometry. For substrate, I choose and click here substrate, assign it a substrate. The patch the face, so I just shift the face and select the patch here, assign it. The ground is also face here, assign. Well, the port. So the port selection is pretty easy here. So I just have to select 2 points. So point 1, point 2, and basically that is. If I have more substrates or if I want to simulate, for example, array, then I can add here more patch, more grounds. If it's multi-port geometry, I just simply add multiple ports here or even lumped elements. So it's pretty straightforward. Everything is set here. And now I can go to physical settings. Our physical settings are the same straightforward as the previous step, which was geometry assignment. I just select here single frequency or multiple frequency. So let's go with the frequency sweep, 2125 megahertz, 22275, and with the step 25. In case if I have multiple ports, I can select to excite them simultaneously as well, but this is an option here because I have only one port here. Then I just go to step straight and I can assign material. So this is the material database. I will select FR4, but by the way, I can also create a new one and save it to the library. So once you just create a new material and save it to library, you can reuse it anytime. So I just select R4, apply it, by the way. So it's a very nice thing to have. So they can just show the last material I choose. Then for ports, everything is defined automatically here. By the way, in case I want to simulate phase array, for example, I can define the phase shift angle. And basically that is, so I selected everything. So I can just simply press run button and start simulation. In this case, mesh will be created automatically. But if you want to just mesh manually, you can also go to the manual meshing. So let me quickly show it. So I will, I will click here to prepare automatic mesh, just to start from. So the geometry is meshed. We can take a look. And if I'm not happy with that, I just can simply go to the manual meshing, select the solid, and I can select edge, just simply say clicking. So I say that I want to select edge, not face. I just click here, and then I can adjust actually the size here. I don't want to do that right now. Let's go back to physics and just run the simulation. So in order to run simulation, the software asked me to save the case. Okay, let's do it. I'm safe, and the simulation is going now. So it will take a few minutes to see results while we simulate the software, simulate the case. So let me show you one very nice feature here. This is a support chart. Actually, there is always somebody from our engineering team online, and anytime you have any question or some problem or anything else, you can just simply go here and start your live chat. So yeah, let's just say hi. Can you help can you help me? I can even just make a screenshot like this and put it here. So that somebody will answer. All right, so we see that one of our support agent just responded me. So thank you, Brice. So you just see as the, so thanks. See you. So we will have result in the few seconds. Let's look what we have here. So we have far field, and we have electric field here as well. Then we have radiation pattern in Cartesian and polar coordinates. And we have frequency chart as well. You can see here as parameters, VSWR, impedance, reactance, resistance, accepted power. Even more, for my convenience, the software prepared PDF report. So let's just take a look. I can share this PDF report with a colleague or customer, or actually upload to my system for the track record. So this file just contains all the information needed. One click, I can export all data into the CSV file or spreadsheet. Now, what that all is about. So I'm here to make design. So if I want to simulate another case with, let's say, different material for substrate, I just simply change it here and press run button and just simulate it again. Even more, if I want to change something, let's say, for example, I want to make the geometry a bit different, or this tail of F antenna a bit shorter, for example, I just simply go back to my favorite CAD software, do that adjustment, and save save cut file in neutral format, step format again, and just simply replace it here. So I already prepared one. So I say I want override. So this is IFA modified step file with a bit shorter tail of F antenna. And basically this is reloaded here. You see it's a bit shorter. Everything is here. So all settings are preserved. I just simply can go to physics here and press run button and get the new results. I hope you enjoyed the demonstration as I did. Hope to see you as a customer and help you designing antennas and other radio frequency cases simply and fast enough. Thanks for watching.